Welcome to Brain Vision.
Here, the total kinetic energy, the total kinetic energy for part A would be equal to the translational kinetic energy of the center of mass plus the rotational kinetic energy. And this would be equaling 1/2 times the total mass multiplied by the velocity of the center of mass squared plus 1/2 times the moment of inertia of the wheels multiplied by the angular velocity squared. And so this is going to be equaling 1/2 times the total mass multiplied by the velocity of the center of mass squared plus 1/2 times 1/2 times the mass of the wheels times the radius of the wheels squared multiplied by the velocity of the center of mass divided by the radius of the wheels quantity squared. And so this is simply going to be equal 1/2 times the mass total plus the mass of the 1/2 times the mass of the wheels multiplied by the velocity of the center of mass squared, and we can then solve. So this would be equaling 1/2 times the total mass of 1,170 kilograms. So this would be the total mass plus the 1/2 times the mass of the wheels, and then multiplied by the velocity of the center of mass, 95 kilometers per hour, multiplied by 1 meters per second for every 3.6 kilometers per hour, quantity squared, and we are getting that the total kinetic energy is 4.07 times 10 to the 5th joules. This would be our answer for part A. For part B, the fraction of kinetic energy in the tires and wheels would be equaling the rotational kinetic energy plus the translational kinetic energy of the wheels only divided by the total kinetic energy. And so this would be, we can say that this would be equaling 1/2 times the moment of inertia of the wheels times omega squared plus 1/2 times the mass of the wheels times the velocity of the center of mass, because the velocity of the center of mass equals the velocity of the wheels squared, divided by here 1/2 times the total mass plus the multiplied by the velocity of the center of mass squared plus 1/2 times the moment of inertia of the wheels multiplied by the angular velocity squared. And so this is going to be equaling 1/2 times 1/2 the mass of the wheels plus the mass of the wheels times the velocity of the center of mass squared divided by 1/2 times the total mass plus 1/2 times the mass of the wheels multiplied by the velocity, the velocity of the center of the mass squared. Of course, 1/2 is going to cancel out. The velocity of the center of mass is going to cancel out, and we have 3/2 times the mass of the wheels divided by the total mass plus 1/2 times the mass of the wheels. And so the ratio would then be equal to 210 kilograms divided by 1,170 kilograms. And we are getting that the kinetic energy rotational plus the translational kinetic energy of just the wheels divided by the total kinetic energy, this is equaling 0.18. This would be your answer for part B. For part C, we then it is beneficial to draw a free body diagram. Going up would be force normal, going down would be mg To the right would be the force of the toe, and then going to the left would be 4 times the force of friction, because of course there are 4 wheels. We know that here the angular acceleration of the center of mass would be equaling, rather, my apologies, that doesn't make sense. The linear acceleration of the center of mass equals the angular acceleration divided by the radius of the wheels. My apologies. So we can then say that the sum of the torque is going to be equaling to 4 times the frictional force times R, and this would be equal to the moment of inertia of the wheels multiplied by the angular acceleration of the wheels. We can say that this is going to be equaling 1/2 times the mass of the wheels times the radius of the wheels squared, multiplied by, we'll plug this in, the acceleration of the center of mass divided by the radius of the wheels. Sorry for it being so cramped. And so we see that the force of friction is then going to be simply equaling to 1/8 times the mass of the wheels multiplied by the, my apologies, the linear acceleration of the center of mass. And so applying the sum of forces in the x direction, this is equaling the force of the toe, rather, minus 4 times the force of friction. And this is going to be equal to the total mass times the linear acceleration of the center of mass. The force of the toe is then going to be minus 4 times 1/8 times the mass of the wheels multiplied by the linear acceleration of the center of mass. This would equal the total mass multiplied by the linear acceleration of the center of mass. And so we find that the acceleration of the center of mass will be equaling the force of the toe divided by the total mass plus 1/2 times the mass of the wheels. And this is equaling 1,500 newtons divided by 1,170 kilograms. And for part C, we are getting 1.28 meters per second squared for the acceleration of the center of mass. This would be our answer for part C. For part D, if the rotational inertia was ignored, then we simply have that the sum of the forces in the x direction is giving us the force of the toe equaling the total mass times the acceleration of the center of mass. And so the acceleration of the center of mass is equaling the force of the toe divided by the total mass. And this is equaling 1,500 newtons divided by 1,100 kilograms. And we have that the acceleration of the center of mass is equaling 1.364 meters per second squared. Now the part D wants us to find the percent error. So this would be equaling the change in the acceleration of the center of mass divided by the true acceleration of the center of mass times 100%. And so this would be equal to 1.364 meters per second squared minus 1.282 meters per second squared divided by 1.282 meters per second squared. And we find that the percent error with making the approximation is approximately 6%. And this positive the positive sign essentially indicates that our approximation is 6% over the true acceleration of the center of mass. This would be our answer for part D. That is the end of the solution. Thank you for